This entire scene was created with a fisheye camera and only took a third of the number of images you'd normally need with 3D Gaussian splatting. That's the beauty of NVIDIA's new 3D Gaussian unscented transforms. You can use really wide angled lenses and capture a whole scene with a whole lot less images. And I'm gonna dive into the project and give you my first impressions. And at the end, I'm gonna show you how to get this running on your own computer so you can start doing your own tests. So let's dive into NVIDIA's new ray trace based radiance field project, 3DGRUT, or 3DGRUT. I don't know what they want to call it, but let's dive in. Like always, I like to start out with the project page. So this is called 3DGUT, or 3D Gaussian Unscented Transforms. So what they're doing is they're using ray tracing techniques to create their initial Gaussians of the scene, and then they use a transformation to splat those onto the view, and in the end, you practically have a 3D Gaussian splat scene, but because we use ray tracing, we're able to use fisheye images and fix for things like distortion, all sorts of neat things. So as I'm just kind of scrolling through this, you can kind of look at these yourself. But one thing I like to point out, if I move back up to the top, is showing you have these highly distorted fisheye lenses. And if you want to use a fisheye lens on a scene like this, in 3D Gaussian splatting, you have to undistort it. And that causes issues around the edges, and you end up with not the best looking results. As you can see here, you can see with even the fisheye GS project, things don't look as good. So they're fixing a lot of problems using ray tracing in the project. Also, rolling shutter is an interesting thing. So with rolling shutter, things don't necessarily look right. They're kind of skewed, but you're able to fix it using the ray tracing effect. So will things kind of look like it's tilted to the side from the rolling shutter. Now you see it looks correct. So pretty cool. One other thing you can do is then, since you're ray tracing the scene, you can put in all sorts of things like glass and different things like that, which I'll show you as we get into this project. Well, enough about this. Let's jump into the project, which is called 3DGRUT, because there's really a ray tracing and an unscented transforms project that got pushed into one mega project. And it's pretty cool how they have one project to do multiple things. And there's a whole lot here to get into. As I show you some results, we're going to come back towards the second half, and I'm going to show you how to install it and run it on your own machine. Just forewarning, at the time you're watching this, if it's in, let's say, mid-April 2025, it says Windows support coming soon. So I'm going to show you how to do this on Linux. And no, it does not work on WSL on a PC because it requires optics, which only works on native Windows and doesn't work with WSL. So that's a bummer for now, but you'll probably learn enough here that when it comes out on Windows, all you have to do is build it and you can start running it the same way I'm going to show you. Timeout. Well, I say in this tutorial, this is technically for Linux. That is true, but also not true. There's nothing about this that actually won't run on a Windows machine. It's just there's some problems with it. However, if you jump into the issues section of the GitHub repository, people have successfully installed this on Windows. I have too, but you cannot run everything. So if you want to train data from a fisheye lens, you can follow this tutorial and follow the GitHub issues, which I'll link in the description of this video on how to install it. But just know the viewer might not work for you depending on how you set it up. And I know the playground definitely won't work. So if you stick to the 3D Gaussian unscented transforms, which uses Gaussian splatting and not just pure ray tracing, you should be able to use this. So anyways, let's get back to the tutorial. All right, so let's jump into the results. There's a whole part here about rendering your checkpoint. So that's what we're gonna do. And I'm just gonna show you how easy it is to bring up your results. So it's, again, command line based, no surprise. And I have copied what I want to do to run a set of results. And just gonna copy this like so. And all you're doing, if it's just like other 3D Gaussian splatting that you've done, we use Python and we're going to pass through what's called a config file with some different parameters. And then we're going to tell it to launch with a GUI. I'm not going to get too deep in this until I get to further down in this video, but let's just launch this and you can see what it looks like in real time. It's going to load your images and it's going to launch a viewer, which is really nice because they packaged this whole project up with an interactive viewer to look at your results, which is something that a lot of these projects don't necessarily do. You can also export a PLY file that you can then bring into other software like Supersplat and edit and view. So while this is loading, I'm going to bring up the images so you can see what I used to make this scene. So I'm going to be showing you my kitchen. So hopefully my wife doesn't see this video, but here we go. If I go to my data folder, I did my kitchen, and I have these 180-degree fisheye image pictures. And it doesn't have like that circle with the black cropping around it, but it is super wide. I use an APS-C camera. So it's a crop Sony camera with this, I think, $105 lens I got used from B&H Photoed. I think it's normally only a couple $100. So maybe not the best camera in the world. You can also see, because it's a crop sensor and it wasn't the brightest, I do have a lot of noise in the photos and things just aren't super sharp. I took these almost 2 years ago, I think a year and a half ago. So they're an old image set. And since then I've learned how to use this camera and lens combo much better, but it was a good test set. So things aren't super sharp and crisp in the imagery. So you wouldn't expect that in the results. All right, so let me just bring up the viewer. So I'm gonna make it nice and big. Unfortunately, for some reason, I cannot scale the UI elements to look the size they should. So on this, they're gonna look tiny on your screen. I apologize, but it is what it is. But if I bring up the GUI, you notice I can look around, which is nice, and you can see those pictures in a 3D model result. And then the first thing I always notice I have to do is I gotta change my mode from free camera style to first person. Bam. So now I'm in first person mode. I can use the WAS keys and kind of move around. There's my cat even sleep on my fridge. And because I had this super wide angled lens, I got the floor and like baseboards and all these hard things that are hard to capture if I had like used my iPhone with not such a wide lens. I even got these floor reflections. So let me just kind of get over there. You can see the reflections tracing. But again, it's not super sharp. So it's not like the sharpest you've ever seen. And that is not necessarily because of the project. That is because the input imagery wasn't the best. I have looked at some of their example data sets that are extremely sharp and extremely high peak signal to noise. So you have this really clean looking imagery. But the fact is, I capture this not with a ton of photos. So if I come here, I can actually hide the radiance field. And now I'm showing the point cloud. In fact, I can turn off some elements in this tree as you explore, and I can make the points a little bigger, like so. So we got your points. There's a point radius you can't really see. So now you're seeing the points. So these are the points that the ray tracer was able to create on the scene before then it transformed it to a splat. So you get this nice, great looking scene, lots of good geometry. Of course, it always picks up like edges really well and not so much like the walls and the ceiling. But even so, I can go to one of these cameras. I can even click on one, hit fly to, and then let's show again. And you can see what that looks like. So looks pretty good. When you jump to one of these cameras, another thing I noticed with this viewer is that it now takes the camera property. So now we're seeing this with that really ultra wide look, which is kind of cool. You get some appreciation. I don't know how to adjust like the yaw and pitch of my camera when I move around too. So you notice it's kind of weird, but it's giving you a good idea of like the fidelity that you can get. So here's the kitchen. It's looking pretty good. A few things I do notice as well is, although I only took 205 images, you can see they're really well dense. It still does a good job at keeping like these reflections really smooth in the imagery, which to me is really important. So if I again hide this, you'll see I have a lot of cameras at like every which direction, which was my goal, was just to like walk around and way overshoot. I probably could have done this whole scene. As you can see, I took like a high and a low. I could have probably done this whole scene in 100 images or less. But if I did that, I might have had less of this nice shadow tracing coming through because it's going to jump around a bit more when you don't have as many images. And I always lose with this camera. I lose orientation with that yaw and pitch, but there we go. So it looks pretty good. That's probably my best test scene so far. And I did a few other scenes as well, which I can as well show you. But first, I want to load up the sample Lego bonsai so you can see how sharp this can be. Okay, so here's the Lego bonsai scene. And as you can see, things to me look a lot sharper on this. This wasn't fisheye necessarily, but just showing you how good the results can look on a different type of camera and better, sharper imagery. This was taken using video. It looks really good. You can see a lot of detail like right through here on the blanket sitting on and on the bonsai itself. It's actually made out of Legos. I'm just gonna fly to a couple of these. Nice thing about the viewer is you can pick a camera and click fly to, and it'll fly to the different viewpoints. So this is looking pretty cool. Again, you can get appreciation for the scene. It's really nice. One thing I didn't show is that in this as well, you can hit add cameras to your trajectory and move around. And then you can hit render trajectory and it makes a quick video, which is really nice as well. So if you want to make an animation of a scene, you can easily do that as well inside of here. You can even change some of your views. So you can see like the distance, which I think things might not work on that. You can see like the density, hits, things like that. If you are a data scientist, this might be helpful for you to troubleshoot your view. So one of the beauties of this project isn't just these good results that to me, they look as good as the 3D Gaussian Splatting base project. So you're not going to be like, whoa, these are the best I've ever seen. But it's the fact that I can use a fisheye camera. So instead of taking hundreds, like that kitchen, I took me 600 photos using my iPhone 16 Pro in the ultra wide mode, which is still a wide view. It still took 600 photos to capture everything. And I did it in 206 with just one fisheye lens, which means you get a whole lot more in one image. So you have to take a whole lot less, which is a big deal. But another big deal is the fact that now you have ray tracing. You can start using some of these cool ray tracing effects in a scene. So I'm going to load up a scene in what's called the playground, where I can bring in meshes and mirrors and all sorts of cool things. And now you can start to see the beauty of this project. So let me just show you that. The playground is the same viewer with some other modifications added on. All right, so here's the playground. It's going to run kind of slow on my screen, I think. I have this running really big, so I might window this. I know that's not going to be ideal for this recording, but it will speed things up a little bit. So let's try that. Yeah, that's a lot better. But what you can see here is I got this like glass orb here and it's rendering the scene. It's ray tracing the scene through that orb. This scene doesn't look perfect. There's me standing next to it. I purposely didn't make this look perfect because I have it in fast rendering mode. If I go here and I make it high quality, things will get sharper, but it takes a lot longer. So when you're using ray tracing, it takes a lot longer. So every time I move now, it is basically catching up the rendering. So I'm gonna make this fast just to give you an idea, but you can easily have these cool assets on your screen. We can come in here and I will say I want to change something. So let's go add a primitive. Let's add this quad, which should be a mirror. And so now I got this quad and it's glass, but I'm going to make it mirror and it's right there. So now I have this mirror in the scene. So now I'm starting to see like this orb and a mirror and I'm behind it. And I can take these things and I can move it around like so, make it up and down. Let's put it behind my guy. There we go. So now you're starting to see I have like a mirror behind me and you're starting to get these ray trace effects. I'm going to try to make this big again. Again, things will just move kind of slow, but you can do that. And it's just playground. You can see how different things work. You can play with all sorts of things. I have a sphere, but I'm going to put a new sphere in there because I think they look cool. I'm going to hit add primitive And then you can, from here, it's really hard to see on the screen, but you can change these things from like a mesh. Need to move it, of course, a little bit. So let's see here. There we go. It's a diffuse mesh, or I can make it something else. I can even see, you can see that mesh through the glass. But I can go and I can make that a checkerboard. I can make it all sorts of things. Let's actually make it glass. I think glass is kind of cool. So we got these two glass orbs, and they do all these cool effects on each other. So this is kind of the beauty of ray tracing. Things aren't as fast, but you can do all these interesting effects. And they have this whole playground. So if you find this interesting, it's something that you can play with. You can do all these really cool things with. You can bring all these different objects in they have in the playground. You can bring in your own object. I think it just has to be like a GLB file type, and you can start to build up a scene and render out a fly through of it or whatever you want. It's a pretty interesting thing. You can even change your rendering. So here I go. I got a fisheye rendering. You can change different ways to view. I don't know how to navigate this fisheye rendering, but this is basically what a fisheye camera would look like. Pretty interesting, the things it can do. And again, I have this in fast mode. It looks a lot better if I make this in a fast, not the fast mode. And you can even, from here, you can record a video, all sorts of cool things. Looking at the evaluation results, I'm going to look at the unscented transforms because that's the version that's going to run really fast on your computer. You're going to see that your results are on the synthetic data really high PSNR, which is to be expected because you have like perfect data. Here's another one where you have more in your 20s and 30s. If you were to compare this against your Gaussian splatting projects like PostShot or the original NVIDIA code, you'll notice that your numbers are going to be very similar to this. So again, this is not going to blow your socks off, be the most amazing you've ever seen. It's just the fact that this project itself is so much more flexible with camera types and distortions and things like that. So that's the beauty of that. And one thing I didn't actually point out at the start of this project is I get further up, when you go to run this stuff, there's two different ways to train your data. There is a 3DGRUT and 3DGUT. And basically one is pure ray trace the whole scene, and the other one is ray trace and transform it into like a splat. And that's really cool because if you want to keep it pure ray tracing, you can do a bunch of other cool effects. Or if you just want it to be really fast, you use 3DGUT. So when I show you guys how to install this and run it, I'll go over that really quickly. But just know that this project is really two projects in one. So one thing I didn't talk about is what does your results look like when you export the results as a PLY and then take it into some other software. So I went ahead and made two different scenes. First is an homage to NVIDIA who created this project. And this was using an iPhone. And this is the exported results in Super Splat. And I did not clean up the data at all. There's a little bit of floating spots like right here. But to give you an idea of the results, this was taken with my iPhone and I was walking a circle at the GTC conference and I was moving kind of fast. So not the best looking scene, but not too bad. So you got this object here. When I ran this using Nerf Studio, my results look very similar. And then I'm just going to go look at one more version. This is my front porch. So now you all know what my house looks like. Again, this was taken back in October. I think I took 40 photos to make this scene. And one thing I noticed when you export to a PLY, you do lose a little bit of the quality. So you can see like these don't look as good as if I was to show you the native version of this. It's kind of like streaky. And then part of the ground missing was just, I think I over pruned some of the splats for this scene, but overall it can look good. It even picked up some fine details, but the render that they have built and implemented in this project is better. So if you are an engineer, a software engineer, and you wanted to use this project because it is open source for your own thing, I highly suggest using the rendering code that they use and building off of that because it's going to be better than these ones. So that is one downside to think about when you want to use this project. And I'm sure they'll get better at it. And I'm already seeing updates to how you run it. All right, so if you've stuck with me this far, I'm going to show you how to install and run this. And also, if you stuck with me this far, please subscribe to this channel because I'm going to make more videos like this, and I want to make sure that you get the most up-to-date information. But the installation on this is pretty easy. There is a gotcha. So what I did was I forked the repository and kind of addressed those gotchas. So let's jump into that. So this is my forked version of the repository, and I always have this read first, like, hey, this is not going to be maintained. However, I do talk about some gotchas. So when you want to run this, you have to, at this point, have CUDA 11.8 or newer, and you have to be on Linux. That's a big deal, but notice they say Windows support coming soon. That's because they do plan on supporting Windows, just they need to make some changes to the backend code to make it work natively on Windows. So we're waiting. Maybe I'll even troubleshoot that for you, but we're not quite there yet. So if you're watching this, it's for Linux. However, when you install it on Windows, it might be a little different, but running it should be exactly the same. So also they talk about GCC. If you have 11 or 12, you can always look that up really easily. I'm guessing if you're on Linux, this isn't all new to you. Let me just start a new terminal session. But you should be able to then say GCC -- version, and I'm on 11.4. If you're on newer than 11.4, then you got to follow some extra things right here. You have to install 11 and then tell it to use 11 when you run your project. And if you have a Blackwell chipset, again, follow these instructions as well. Assuming you're neither of those, you can run this project using CUDA Toolkit 11.8 or newer. However, they have this great installer that they've created, and it makes everything really easy for you. However, it only works on 11.8 or 12.8 of CUDA Toolkit. So if you have one of those, simple as following these instructions. You're just going to clone the project, change directories, and then put in these 3 commands. Super easy. Now let's assume you don't, like I do. I have 12.4. So if I go to terminal and I type in nvcc -- version, it's going to say I have 12.4 as my compiler version. So to run it with that, it's not too hard. The first thing is you're going to, again, clone the project to a 3DGRUT, which is here. So if you go to your home, I cloned it to this 3DGRUT folder, and change your directories. And then you need to set your CUDA version that matches PyTorch. What I mean by that is you just put in this one line here, export CUDA version 11.8.0. And then you need to create a content environment. So just put these 2 in there. And once you've done that, it's going to run through some prompts. Then you need to be in your content environment. So just going to pull up terminal, and I'm going to conda activate 3DGRUT. So now I'm in it, and I also need to change my directory to 3DGRUT. And so now you've got that activated, then you need to export your path. So what we're now doing is telling it to use 11.8 as your build tools and not 12.x, whatever you're on, 4 or 6. And if you put this in here first and then run the script to install, it all magically installs. They have this really cool, complex installer that just handles everything for you. And I've tested this on 2 different Linux boxes now, and it has worked without fail. So just follow these commands, and it's that easy. I promise you. If you are on Docker and you like to use Docker, you have to have NVIDIA Toolkit installed, which is, again, very easy to get up and running. And then you can just run these 3 commands that'll install the Docker image or run it. And then, or that'll build your Docker image, and then you can just use these to run it every time. So super simple. Use whatever version matches your system, and you'll be up and running. I think installing it's the easy part, but I do know a lot of people run into dependency issues, and so I did address that in my forked version, which I'll put in the notes to this video. But once you get past that, their directions on how to run this are almost non-existent. So let's jump into that. So now I have prepare your data. So we need to get your data prepared. I sadly omitted that at the time of this recording because I wanted to get this video made before I go on vacation. However, I'm going to show you how to do it in this video, and it's super easy. So the first thing you need to do is have a folder of images. So let me just take one of my folders of images, and I'm just going to like duplicate it. Let's do my playroom. So I'm just going to take this, I'm going to copy it, I'm going to rename it, I'm going to call it playroom underbar test. Bam, super easy. Then I'm going to delete the sparse in this database.db. Just know that I have this folder of images of my kid's super messy playroom. It was perfect for getting a lot of cool details. And this is what I'm gonna run the project on. One thing to notice, my arm got caught in some of these images. Oops, that's because it's such a wide angle lens. So be careful with that. So I'm gonna show you how to run this. And notice that I have an images folder called images 2. So if you want to run half scale images, you just need to make a downscale images at 50%. I will have that in how to prepare your data further on, but you can just use like ChatGPT to look up image magic to downscale a folder of images, and it'll give you the command. It's super easy on Linux. But the first thing you're going to need is Colmap, because when you run this, you can run it using Colmap as one of the ways to run your data or train your data. So if you don't have Colmap installed, again, I will probably have that in installation notes, but it's also pretty easy. You get Colmap installed. So I'm just going to run the Colmap GUI. So I just go here, I'm going to hit Colmap GUI. I'm just going to launch it. And I'm going to create a notebook as well that'll make this so it's kind of more streamlined and you don't even have to deal with this, but this is super easy. So I'm going to start a new project, hit new. I'm going to go find that folder. So it was my data. I called it Playroom Test. And I create this new database. So I'm going to call this database.db, and I'm going to put it in the root of my project folder where I have the images folder in. And then in my images, again, I didn't mention this, but images need to be in a folder called images. I'm going to click that, hit open, and I hit save, and it's going to create a project file. Then I go to process. So the first thing I'm going to do is called feature extraction. So now if you have a fisheye lens, you're going to pick OpenCV fisheye. If you have a non-fisheye lens, you're going to pick pinhole, or you can pick simple pinhole. So for me, I'm using this fisheye lens. I'm going to use not full. I can use OpenCV fisheye. And then it says shared for all images. So it's saying all the images are going to be the same camera, same parameters. Hit extract. This part goes super fast. It should be done in like less than a few seconds here. Okay, it's done. I'm going to close that. Then I go to feature matching. Again, I'm going to do exhaustive because I didn't take every picture in sequence. But if you take like video extraction, you want to use sequential. So I'm just going to hit run. Again, this shouldn't take very long. I think it might already be done. Yep, already done. Well, it took 0.04 minutes. If you have a larger data set, this might take a lot longer. And then you're going to start reconstruction. So this is where the magic happens. So I'm going to make this big, and you're going to see what there's 2 photos, and it's going to start incrementally adding photos to the scene and start building it. So, okay, now we got 4, 6, found some good matches, and it's going to start to build up this room. And if I hold Alt and scroll down, I'll make this a little smaller. And Control and up, make the points a little bigger so you have an understanding of what we're looking at. So now we got the room, and it's starting to build the room. So this is this interesting poster out on the walls. There should be a couch right here. Let's make these a little smaller yet. And it's going to keep running until it goes through all the images and refines the output. Again, I told you there's like 40 images, so it didn't take long. It took less than a minute. So now I got my key points. I'm going to hit bundle adjustment. I don't know if I actually need to do that. I don't think it changed anything. I think I already ran that, but it's one thing you can do as well to tighten up your results. And then the last thing I'm going to do is go to File, Export Model. And so now I'm in that Playroom Test folder. You got to create a new folder. I'm going to call it has to be called Sparse. You got to create another new folder called 0. And then you can save it there. So I should be able to go to now my folders, and I have this sparse 0, and then I have these called cameras.bin, points3d.bin, images.bin, and your project. So there you go. That's what you need. I can now get rid of Colmap. And so now I have my data ready for training. It seemed kind of complicated. I will make a script on how to do that so you don't have to do that every time. You could also run Nerf Studio as well because it does the same thing. It will put your results in what's called a col map folder than sparse than 0. So you've got to take all the images from sparse 0 and move it out of that col map folder and into the root folder. Hopefully that makes sense. Now I want to train the data. You'll see it says train 3DGRT or GUT. I'm going to assume you want things to be fast. So we're going to do the GUT scene. So if you go here, you'll see the train bonsai is what we want to follow. And it's got runs the train.python, a config name, which is the colmap method, the path to the data, the output directory, and so forth. So I'm just going to copy this. I'm going to open up my trusty notepad, and I'm going to create a new line. And this will probably be nice and small for everyone. So let me just copy, paste. There we go, make this big. So I'm going to leave some of this alone, but now I want to update to this to what I wanted. So I just created a folder called data playroom underbar test, which is great. And then the output directory, I'm going to leave it as runs. Always leave that as is. And I'm going to call this playroom test. Well, I think I already have one called test. So I'm going to call this playroom test 1 3DGRUT. And then it's going to downsample to 2. You can make it 1 if you don't want it to downsample, or I think you just get rid of this altogether. It won't downsample. But then I will make sure in the GitHub I also have a few other things. So I want to see it with my GUI. So if I go here and copy with GUI, you'll be able to visualize the training, which is really cool. And then export PLY enabled true, like so. Now I'm going to get a PLY at the end as well. So just going to take this line, I'm going to copy it, go to terminal, I'm going to paste it and hit enter. And it's going to load up my images and things are looking good. And it will start training it in a few seconds. I also told it to launch the visualizer. So if I didn't say with GUI true, it would just run it right here on the screen. You wouldn't see the visualizer, which I think makes things faster, but is not as fun. So if you just want to train things and walk away and come back and get your results, you can do that as well. So give it a second. It's loading the visualizer, and then we can watch it interactively train for a few seconds. Okay, so here's the visualizer. And I always noticed the first time I ran this, I thought something was wrong because nothing was happening. It's because when it launches the visualizer, it is not training. So you have to checkmark train at the top right, and then it's going to start training. So let me just zoom out. This is going to get probably real choppy because it's using all of my system resources. But you can see things start to come into focus. You'll see the scene slowly start to come in focus, and it kind of like grows. If I go to look at my terminal, you'll see the training steps, how long it's taking, and if I close the GUI, things will go a lot quicker. So I'm going to close the GUI and let it keep going. Notice it says terminating the training from GUI window is not supported. Please terminate from the terminal. Okay, so I actually never tried this. Apparently you can't close the GUI while it's training, so either have it on or off. But as it's going, you'll notice that it prunes every certain amount of steps and keeps going. So I'm just going to quit the training because this is going to take a while. It takes as long as 3D Gaussian splatting does. All right, so I killed it. My system is taking a big sigh of relief. But let's assume it's done training. Then you want to visualize it. One thing I didn't mention is when you train with Bonsai, you can also train with MC-MC. So you can just pick one of these as well, and it will have an MC-MC strategy. So just kind of play with the different versions, but you saw how I put that together. So the last thing you want to do is you want to visualize your output. So you're just going to take this, you're going to copy it. You're going to go to your notepad like so, and then it's going to have the wrong config name. So just pick the config name you used. So I use colmap like so, and then your path. So you can just kind of copy what you already had from above. And again, I'm going to make a script that will just take care of this all for you guys, but I haven't got there yet. So you can just follow along. Like so, the GUI will be on, but the thing you want is you want to resume from your checkpoint. So to get to that, I can just go find one that I've already ran. Actually, I'm not going to run Playroom test because I didn't actually finish that. But I do have a Playroom data set. So if I go to my runs folder, there should be one called Playroom in here. And there's a checkpoint. I'm going to copy that. Excuse the dog. And I don't need all of this. I just, again, need from runs on. Like so. Cut that and put it right there. So now I should be able to take this, copy it, go to my terminal, paste it, and just going to load up that scene. I ran into an error because I realized I think I used the MC strategy on this one. So I just got to go here, and the config name I want was this one, the MC. So copy that, go back to my notepad. So you can see I'm not perfect when I do some of these projects. And I'm going to paste it. Now I want this whole line again, like so. I'm going to copy that, go to notepad, paste it, and now it should run. All right. And so now I have that scene loaded up on my screen, and you can now go change again. Make sure you change your view to first person. Makes things a lot easier. And now I can move around using my WAS keys and see what the room looks like. So these are pretty cool results. You know, like not the best, as you can tell, my arm in some of the pictures as well. But this was me attempting to take this whole room in the least number of images possible. I think I did it in 40, and I should have done it, or actually this one 30. I probably should have done it in less. So, all right, I probably should have taken some more to capture some details like in here, which I may have just straight up missed, but pretty cool. So if you found this interesting, I'll make sure I get the GitHub repo fork that I've made up to date with all those little gotchas. And one thing I also want to add is this is so much easier to run with a Jupyter notebook. So if you have the notebook, you can just kind of have different paths you want to take and then just change a few variables and everything works. So I'll make sure I do a follow-up video on how to use Jupyter Notebook. You could also make a Gradio interface. There's a bunch of different ways you could run this because the code is so easy to work with. So I hope this is helpful. If there's something you want me to dive deeper into on this video in a follow-up video, let me know. I'll be happy to make that. And I'll see you guys in the next video.